Hi everybody, this is permutation part 2. Now let's look at these questions. If I have a word Happy, I have 5 letters here. How many ways can I arrange all these letters? So if we do it this way, number of ways to arrange all these letters. If you calculate this way, 5 factorial, you will get the wrong answer. Now let's check. Take out your calculator. Press 5 factorial, which is 120. This is not a correct answer. The correct answer should be 60. We only have 60 ways to arrange all these letters. So how do we get 60? For this type of question, we need to calculate this way. Because we have 1, 2, 3, 4, 5 letters, it will be 5 factorial, but there are 2p. These 2p are exactly the same. So try to think, let's say you have two objects, A and B. How many ways can we arrange all these letters? It will be 2 factorial, right? So these 2p, they are the same. We need to divide this answer by 2 factorial. So this way is a correct way. 5 factorial divided by 5 factorial divided by 2 factorial. You will get the correct answer, which is 60. Okay, but you need to be more careful. Some students, they will think that we have 2p here, right? 2p, so we divide the answer by 2. In this situation, if you divide the answer, this answer 5 factorial by 2, you will still get the correct answer, but the concept is actually not correct. This is just a coincidence. 2 factorial is equal to 2, right? 2 factorial is equal to 2 times 1, which is equal to 2. So now let me change the question a little bit. If this time I have 3p, from the website here, we know that the correct answer should be 120. But if you do it this way, number of ways to arrange all these letters. How many letters do we have here? 1, 2, 3, 4, 5, 6. So 6 factorial. And I have 3p, right? Divide by 3. Try to press your calculator. 6 factorial divide by 3. You get 240, which is not a correct answer. 240, this is not correct. So the correct way should be divide this 6 factorial by 3 factorial, not 3. So try to think, if you have 3 letters, A, B, C, they are different. How many ways can we arrange them? Not 3, right? But 3 factorial. So that's why here we should divide this 6 factorial by 3 factorial, not 3. Six factorial divide by 3 factorial. Okay, so this time we should be able to get the correct answer. 6 factorial divided by 3 factorial. 120. Yes, our answer is correct. This is the correct answer. Okay, this time let me change a little bit the questions. Now let me add one more A here. So I have 2A, 3P. So how many ways can we arrange all these letters? Let me show you the correct answer first. We should be able to get 420 ways, right? So how do we get this answer? Number of ways to arrange all these letters will be equal to, first we need to calculate how many letters do we have. 1, 2, 3, 4, 5, 6, 7. 7 letters. So it will be 7 factorial. But there are 2a. So we have to divide by 2 factorial. And we have 3p. So we have to divide by 3p again. So now, let's press our calculator. We should be able to get 420. So when you press your calculator, you need to be more careful. If you press this way, 7 factorial divided by 2 factorial and 3 factorial. You press equal, you cannot get the answer. You need to add a multiplication sign between these two. Okay, so the correct answer, 420. This is the way how we solve this type of question. Divide 2 factorial because 2a, 3 factorial because 3p. Okay, let me change the word, go back to HAPPY. Let's try some other situation. Let's say the question wants us to arrange all the consonant need to be together. Okay, that means this means that all the consonants need to be next to each other. So how many ways can we arrange it? How many consonants do we have here? We have H, P, P, and Y, right? How many vowels we have here? We have only one vowel, which is A. Now, since the question requests that these 4 consonants need to be together, so we can consider these 4 letters as one unit. Consider these 4 letters as one unit. So here will be another one unit. Okay, so the number of way. So we have 2 units to be arranged, so it will be 2 factorial. And don't forget, because this HPPY, they still can be arranged among them. It can be HPYP, it can be PPHY, and so on, right? So we have 4 letters here, 4 factorial. But there are 2p, so we have to divide this 4 factorial by 2 factorial. Okay, so here we can simplify them. 4 factorial, which is equal to 4 times 3 times 2 times 1, which is 24. Okay, let's check whether our answer correct. All the consonants must come together. All the consonants come together. Okay, so we have 24 ways. Okay, now this time let's change the solution become this. The 2p need to be separated. Means that the 2p cannot be together. So we can do it this way. First, we find the 2p being together first. Number of way. Okay, 2p next to each other. This is not the final answer. Next to each other. Okay. So if we want this 2p being together, now we have H, A, P, P, Y. So we consider this 2p as one unit. And how many units we can arrange here? 1, 2, 3, 4. So it will be 4 factorial. Okay? This 2p is actually the same, so you don't have to times 2 factorial. If you times 2 factorial, because they are the same, you have to divide this 2 factorial by 2 factorial again, which is actually equal to 1, right? So since this is the same, you don't have to times 2 factorial. If this is, let's say, different letters, then you have to times 2 factorial. Okay, now, so this, actually you don't need to write it. So 4 factorial will be 24. But this is not the final answer. Okay, so we have to find the total number of ways to arrange these letters with no restrictions. So number of ways. This is no restrictions. So we have how many letters? 1, 2, 3, 4, 5. 5 letters. This will be 5 factorial. but there are 2p divided by 2 factorial. So this will actually give us, let me press my calculator, 5 factorial divided by 2 factorial. So this will be 60. So our final answer, number of way, two p are separated. Okay, so total number of ways to arrange all these letters with no restriction will be 60. And this 2p together we don't want. So we have to take 60 minus 24. So which is 36. Okay, so now checks by using this website. No two, okay, let me see. No two, okay, this one. So it will be P, generate. Okay, our answer correct, 36 way. Okay, now let me change the word a little bit. Let's say we have 3P. We have H, A, P, 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 Y. We want this 3P to be separated. Okay, let's check the correct answer. Okay, you will notice that all these P, they are not next to each other. We have 24 ways to arrange them. But you need to be more careful. Some students will calculate this way, which is actually not correct. Number of ways, no restriction, will be 60, right? So if you calculate this way, number of ways, all 2p together, not all 2p, all p together, all p together, all next to each other. So if you want to find the number of arrangement for this situation, we have, let me write over here, H, A, P, 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 Y. Now we have 3P. We consider this 3P as one unit, like what we did just now. So we have 1, 2, 3, 4 factorial. Okay, the 3p is actually the same. You don't have to times 3 factorial, then you divide by 3 factorial, because here you will get 1, right? Okay, now you calculate this way, 4 factorial, which is 24. You take 60 minus 24, 60 minus 24, so that to get no 2p come together, you will actually get 36, which is not the correct answer. The correct answer should be only 24. So why we cannot calculate this way? Okay, when you minus this, you only consider about 3p to come together, right? So some situation, H, A, let's say P, Y, let's say PP. Let me check. H, A, P, 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 Y. You didn't consider about this situation. This also don't want. This don't want either. Because the question want all the P need to be separated. Okay, let me write over here. All P needs to be separated. All P need to be separated. So if you only consider all P together, you minus this. But there are some cases that you haven't considered yet. 2P together also cannot either. Also cannot, right? So you haven't considered about this situation. So in this type of question, in order to get the correct answer, we need to do it this way. Okay, so first we can write H-A-Y first. H-A-Y. So since the P need to be separated, so we can place here, 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 or here. So we have 4 places here. We only choose 3 of them. So we can do it this way. Number of way, 4p3, 4p3. Why 4p3? Because we have 4 places here, but we only want 3 of them. Okay, the p might be filling here, here, or here, or here, here, and here, and so on. But you need to be more careful because the 3p are actually the same, so we have to divide this answer by 3 factorial. Okay, so how many ways can we arrange the HAY? 3 letters, so 3 factorial. So these two actually can simplify them. Now just press your calculator, we should be able to get the correct answer, which is 24. 4p 3 24. Okay, so this is a way how we solve this type of question. Okay, now let's look at this another question. The digit 1, 3, 4, 7, and 8 are written on 5 identical cards. How many 4 digits, we want only 4 of them, 4 digit odd number can be formed with this card. So you can do it this way. Number of way. So we need to consider the condition requested by the question first, which we need odd number, 4 digit, and we need the 4 digit. We need to form an odd number. So in order to form an odd number, here we need to put an odd number, right? So we have how many odd number here? 1, 3, 7. So we have 3 choices. So we just write 3. Okay, so total we have how many number here? 1, 2, 3, 4, 5. We have 5 card, 5 number. So we have selected 1 over here, we left 4. So we have 4 choices here. Now after 2 have been selected, we left 3 and 2 like this. So the number of way will be 4 times 3 times 2 times 3. Okay, so the correct answer is 72. So this is actually 4p3. So you can press your calculator, 4p3 times 3. You get the correct answer also, which is 72. Now let's go to this type of question. We want to arrange in a circle. So how do we solve this type of question? The number of ways to arrange n different objects in a circle when clockwise and anti-clockwise arrangement are distinct is given by n factorial divided by n. So why do we need to divide by n? So this is actually the same with this one. So n factorial divided by n is actually equal to n times n minus 1 factorial, right? So it cancels up, you will get n minus 1 factorial. Okay, now let's look at this diagram. Now I have 4 letters here. So how many ways can we arrange them in a circle? So we cannot calculate it as 4 factorial, which is not correct. The total number of ways is actually only 3 factorial, not 4 factorial. 4 minus 1 factorial, which is equal to 3 factorial, or 4 factorial divided by 4, which is equal to 3 factorial. Okay, so why do we need to divide the answer by 4? Why do we need to minus 1? Because now you try to think, if you are A, let's say you are A, I ask you, when the A sit here, D over here, B over here, and C is opposite to A, who is on the right hand side of A? D, right? Left hand side will be B. So if I change it, I change the A, sit over here. Who is on the right hand side of A? D. Left hand side? B. Still the same, right? Even though you change over here, always the same. right? Go back here and here. Okay, this is actually the same with this one, and this one. So that's why we need to divide the answer by 4. Or we can just minus 1, then factorial. Okay, 4 minus 1 factorial. If we have 4 letters or 4 objects arranged in a circle, 4 minus 1 factorial. If we have 5 objects, we want to arrange them in a circle, 5 minus 1 factorial. Y minus 1 is actually this. We have n object, right? So the way to arrange them in a circle, n factorial divided by n. But if you don't want to do it this way, you can just do it this way. They are the same thing. Okay? Now let's try some questions. How many ways can 6 people sit around a round table? So we want to arrange these 6 people in a circle. If this is in a row, we just can get the answer by 6 factorial. But since this is in a round table, in a circle, so the number of ways we need to calculate this way, 6 factorial divided by 6. Or you can just write 6 minus 1 factorial. These two are the same. Okay, let's press our calculator. 6 factorial, 6 factorial divide by 6 divided by 6. You'll get 120. So you try to press 6 minus 1 factorial, you still get the same answer. 6 minus 1 factorial. 120 way. Okay, let's try this another questions. In how many ways can 4 men and 4 women be seated at a round table such that no 2 men sit together? Okay, means that every man need to be separated. So this type of question will be a little bit complicated. You can do it this way. First, I need to explain let me show you this diagram. Now, I have 4 men. Okay, letter A, B, C, D, B men. A, B, C, D, B men. So later on, the women need to, we have 4 women, and we need they need to sit over here, so that all the men are separated, right? Okay, so we ignore about the women first. Think about the men first. Okay, so how many ways can we arrange all these 4 men? Not 4 factorial, because this is in a circle. So the answer will be 4 minus 1 factorial, right? This is what I explained to you just now, because this, and this are all the same thing, right? Okay. So that's why we need to minus 1, 4 minus 1 factorial. Okay, for the next part, you need to be more careful. Now, let me bring in the goal. P, Q, R, S, they are goal, women. So how many ways can we arrange this P, Q, R, S? Here you need to be more careful. So we cannot think that, okay, because now we have 4 letters, we want to arrange them in a circle. So 4 minus 1 factorial. Oh, this is not correct in this situation. Why this is not correct? Okay, let me explain to you. Now, you try to look at this diagram. If I turn it like that, is it the same arrangement? Now, this time it's different. If P sits over here, P is between A and B. So if P changes over here, now this is considered another arrangement. P is between B and C. If we change over here, P is between C and D. Every time that's new arrangement, different arrangement. So in this situation, the number of ways to arrange the all 4 women, it will be 4 factorial. Okay, let me use red color. So this one, you don't have to minus 1 for factorial. So our final answer should be 3. 4 minus 1 is 3. 3 factorial times 4 factorial. Okay. 3 factorial times 4 factorial, which is equal to 144. Okay, so this is the way how we solve this type of question. Okay, let's go to the last part of this video. Just now, when we want to arrange a sum of the object in a circle, so we know that we have to take n object, n minus 1 factorial, right? So when the clockwise and anti-clockwise arrangement are distinct. So for example, let me write this way. A, B, C, and A, B, C. This is different, right? Okay, try to think why these two are different. So if you sit, let's say you are A. So I ask you now, who is on your left? B. Who is on your right? C. So how about this? Who is on your left? C. Who is on your right? B. They are different, right? Okay, so how about this time? The number of ways to arrange n different objects in a circle still the same in the circle, but when clockwise and anti-clockwise arrangement are not distinct. So it's still the same, n minus 1 factorial, but we have to divide the answer by 2. So why do we need to do so? Okay, let me use this diagram to explain to you. Now, I have, let's say I have 4 beans, which are different color. I have blue, green, red, and yellow. Okay, let me write over here. So now, red, green, blue. Okay, let me write smaller. Red, green, blue, and yellow. So in this situation, if we are arranging some beans to form a necklace, the clockwise and anti-clockwise are not important. Okay, what do I mean? Green, blue, yellow. Okay, this is red, green, blue, yellow, and this is red, green, blue, yellow. You will notice that they are different, right? And this is go this way, this go this way, but these two actually the same. I only need to arrange one arrangement. I can form 2 of this. Okay, let's see. How do I change this to this? I just need to arrange this way. So in order to change this to this, I don't have to rearrange it back. What I need to do, just turn it over. Because this is a necklace, right? We can just turn it like this. Turn it over. Now it forms another thing. So which is green, red, green, blue, yellow. Red, green, blue, yellow. Turn it go back this way. It become red, green, blue, yellow. Okay? So that's why we need to divide the answer by 2. Okay? So now let's try one more question. Let's go back to this. Liu buys 6 different beans, different color, to make rings. So this time we can turn it over like this, right? So when we find the number way to arrange them, need to divide the answer by 2, remember. Find the number of ways to arrange the beans if there's no restrictions. So for A should be no problem, number of ways. In a circle, right? So 6 bean, it will be 6 minus 1 factorial. But this is not the final answer yet. because we can turn it over. The clockwise and the clockwise are not listing, so we have to divide the answer by 2. Okay, just press your calculator. 5 factorial divided by 2, which is equal to 60. Okay, now let's go to last one, B. 2 special beans must be next to each other. There are 2 beans must be next to each other. So let's say I have a circle. I have 6 beans. 1, 2, 3, 4, 5, 6. Let's say I want these 2 beans must be together. So consider this as 1 unit, right? So 1, 2, 3, 4, 5. I have 5 units. So because in a circle, 5 minus 1 factorial. Okay? And these 2 can exchange their places times 2 factorial. But this time, because this is forming a necklace, we can actually turn it over. We have to divide the answer by 2. Okay, so 5 minus 1 is equal to 4. 4 factorial times 2 factorial divided by 2. You will get 24. Okay, so this is a way how we solve this type of questions. Okay, that's all for this video. Thanks for watching. See you next time. Bye bye.